presenting our next session. So Zach, you are on.
Hi, everybody. I'm going to be presenting on overcoming challenges of data center operations with open sourced architecture. So as Archana mentioned, I am with AMI. I am the director of our product office, which includes our product management team. And this is within the server track at the OCP Tech Week. So data center operations challenges. This is only one slide I'm going to have on this in our short time, but I could have put a whole PowerPoint together on why data centers jobs for the administrator are never easy. Basically, services are never expected to go down. They should have little downtime if they do. Also, the amount of services continues to expand. The services are getting more complicated, but the focus of this presentation is more on how the data centers themselves are getting more complex. Hyperscale data centers have heterogeneous server deployments, so they're going to have different generations of servers coming in. They're going to have different suppliers of servers coming in. So you can't depend upon a single supplier or a single service contract when in the new data center of today. And especially, this is all about where OCP is heading with its things as well. On some of the other tracks that you might be watching, you can see 5G and other data centers show a similar trend. So even in your enterprise, you might be buying servers from the OCP marketplace now as opposed to going to traditional OEMs. Also, the shift in software-defined infrastructure on these non-branded servers continues to drive this innovation and increases the platform management complexity. So not only do you have to manage your software-defined services now, but you also have to manage the hardware that it's running on. So as a data center or system administrator, how do you manage systems via a single method? Create your own custom management firmware, secure your platform or platforms as much as possible. And to do this, can you leverage open source as much as possible? Because in the economies of today, you got to be penny pinching when it comes to these things. And many times they're not going to even expand your staff, let alone buy some software. So you need to look at using as much open as possible. So if we look at managing your systems via a single method first, go fish. So Redfish has been a common theme amongst OCP for the past few years. And I think most people have become accustomed to it coming from DMTF. And it was supposed to level the playing field for IPMI. IPMI, there are a lot of OEM branded tools and OEM branded infrastructure to manage those systems, but Redfish was supposed to make it simple for everybody to manage any system. But how do you leverage it? Redfish is an industry standard framework using RESTful APIs through JSON. What that really means is as long as you understand the APIs that are available, then it's human readable and you can create tools pretty simply. But creating your own custom tool from scratch, it's possible, but it's complicated. Why do I want to create it from scratch? Isn't there an easier way? So again, DMTF is the one who puts out Redfish. They also put out 2 open source repositories regarding Redfish tools. So the first one, they're both on GitHub, by the way. Redfish tools has useful Redfish related transforms. So it converts from one data type to another, maybe because you're sharing information with a database or with other tools. So this will help you easily transform the data. And you've also got Redfish tool, which is an open source tool for testing and utilizing Redfish services. It's written in Python, so it's very extendable. It's also a language that a lot of people are comfortable with today. Since it's consuming text-based data, it's very simple to use, debug, and look at the information you're getting back. So you should be able to extend it to do your own custom tool from this. You don't need to start from scratch. And here's a Redfish tool example. So you can see here, You're saying what the remote IP is, your username and password, and then a call to system list in this case, and it's going to get the system list. Also, you can get some chassis information and thermal information if you want to do that instead. So you can see it gives some proven examples, even on their website, of how to utilize these services. Higher level projects like ODIM. There's an ODIM talk coming up at 2:30 this afternoon. So they utilize Redfish and can be used for a more complete management stack. So not only do you have Redfish tools coming from DMTF, you've even got Redfish tools coming from other open source projects like ODIM. So you got the idea of maybe how to do some Redfish management at this point. But what happens if my system doesn't have Redfish or doesn't have the management that I need within my system? OpenBMC. This has also been talked about quite heavily at different OCP past events. So OpenBMC is now a Linux Foundation project, and it offers organizations the ability to own their own management firmware. So it offers a stack. You can almost think of it as the Linux kernel for BMC development going forward. So it continuously evolves with new features and supported silicon. New standards are going to be put in there. Say Purplefish comes out in a few years, Purplefish will be added to here as well. And you can leverage the open community's efforts to your own purposes. Also, a very important thing that I know has been coming up in this OCP and previous OCP Tech Weeks is that future OCP platforms will be required to have an open firmware available for their platform. So OpenBMC can be your method to help do that. But it's not as easy as just going and downloading the source. Developing firmware is hard. If you're a new developer to the space, there's no easy starting point for developers. Companies tend to employ large number of engineers for firmware development. So you can't just decide one day that I'm going to change my entire data center's firmware to my own firmware. It requires at least knowledge of what you're going to be doing and also the right resources to be able to pull it off. Also, firmware validation is complicated but necessary. You can do a test deployment on one server, but when you're dealing with today's data centers, you need to really test it at scale. You need to make sure that it will function properly before it goes across your whole wide data center or even worldwide data center. But how can you get started with BMC firmware development then? So obviously going to OpenBMC is one way. But there's also OpenBMC derivative products or projects. So similar to how the Linux kernel is used across a wide variety of Linux vendors, you can see that there are going to be derivative projects for distributions that offer a solid foundation for development. So the OpenBMC will continue to evolve on a daily basis. These distributions or derivative projects will sync with OpenBMC on a regular basis and offer a well-tested, well-aligned solution before delivering it to people. So like we talked about, and then it pulls from the latest source and offers that validated base. And it also fills some gaps in functionality that maybe the OpenBMC community doesn't care about, but you might care about in your own organization. And it provides dedicated support. So instead of having to go to a mailing list to get your support that may or may not come, you can have dedicated support behind it. So companies like AMI provide our derivative project as a delayed distribution of our open source that is linked to here. And we intend to make this a contribution to OCP. In fact, in the next 3 months or so, we're currently working through this with some of our industry partners to make this a contributed OCP project. And for people who don't want to take their running servers and start OpenBMC development on them, we also offer a dev kit, which pretty much allows you to develop your BMC firmware on a AST 2600 part. and also manage a very minor machine and have some virtual sensors that you can kind of tweak to make sure that all of your sensor porting is going correctly. So this offers an opportunity for somebody who hasn't been in BMC development for 10 years or 20 years of their career, like a lot of the people in the industry have been, to get started and leverage these things to get going. So the next topic we had was securing your platform firmware. So this one might have some interesting ideas for the people listening in. So firmware security is a growing concern. And you'll probably hear a lot of NIST 800-193 or platform firmware resiliency from a lot of people here, but this looks at it from a different angle. So firmware usage continues to increase. You have firmware on all over your computer now. You've got it in your power supply, you've got it in the BIOS, you've got it in the BMC, you might have it in your NVDIMMs, you're gonna have it in plug-in cards. You've got it all over the place in your system now, and it continues to become more pervasive. So organizations must assure platform firmware integrity is there. Otherwise, they've got a whole boatload of problems coming to their data center that they haven't seen yet. And if you can get in at the firmware level, it makes it almost impossible to find with higher level OS searching for these things. So you must protect your platform firmware. Data security privacy in the cloud is a top priority because this has all of your personal information now, whether it be your social media, your banking, all sorts of things are in the cloud now. So how can data admins accomplish this? And if we look at it from the other angle, where your hardware root of trust is what you'll hear a lot of people talk about when you talk about ensuring that your platform firmware is secure. But your hardware root of trust is only capable at a static evaluation of the firmware. It will validate it to make sure that this is a properly signed version by somebody that I trust. It doesn't verify that this is the latest version of that firmware. So in fact, you've got two ends of the string that you've got to continue to pull on to ensure your platform firmware is secure. It not only should have a hardware root of trust, but you should also verify that it is a version that is still trustworthy and doesn't have a security issue that was in that earlier version of the firmware. Now, the project that I'll talk about here is Intel SecL DC. So security library for data centers exists to address these concerns. So what this does is you basically have a trust agent running within different operating system levels, and this is all provided as part of the open source that's there. And this trust agent communicates with a verification server or service that utilizes the TPM on these platforms. And utilizing the TPM, you can sign it with a key that's within the TPM so that all communication to the data verification service or server are trusted, so that you know that the trust agent hasn't been compromised, or at least the information you're getting from that system is coming from a reliable source. And now you can leverage the fact that if you put all of your firmware in the TPM event log and all of the hashes, you can now use this to see a flavor of your systems running throughout the data center and ensure that this is a trustworthy system before it even enters the rest of the network in your fleet, for example. And you can do this on reboots, you can do this periodically, you can really make this a complete solution. Again, these things can be complicated. So for those less inclined, a custom shrink wrap solution that leverages this open source and maybe builds more features around it are available from companies that are out there, and AMI again is one of them. But you can go look at the open source, you can try it out. It's all available to you if you want to integrate it with your own infrastructure that's there. So at this point, we've talked about how you can manage your systems with open source or leveraging open source, how you can build your own platform firmware for management if you want, and now also how you can secure your platform leveraging open source. And all of this can happen on a single system or across your data center at large. So when we come to the call to action, system management and system security are complicated items, but open source projects exist to build a base solution. So you should realize that although you might not be ready to invest in these areas financially, you can leverage open source to get you some of the way there or to know what solutions exist on the market. So stakeholders of those management companies should leverage or should research projects to complete their story and make sure that they're properly secured from top to bottom. OCP also offers several forums to help drive conversations. So you got the OpenRMC within the OCP hardware management project for management related items, and you've got the OCP security project for security related discussions. Also, as system management becomes a bigger and bigger thing, the community at large should probably talk about, does it make sense to bring some level of BMC discussion back to OCP since it's been moved out to the Linux Foundation. But that wraps up my section. I wanted to open it to questions. Or
Yeah, Zach,
we ran out of time.
Yeah, we've kind of run out of time, but I also don't see any comments yet or chats in the virtual platform, and I don't see anything on the Etherpad.
Okay.